Barbara Russo of the Free University of Bolzano-Bozen in Italy. I'm here to present a work on towards risk modeling for collaborative AI. This is a joint work with Fondazione Bruno Kessler, Universität Innsbruck, Fraunhofer Italia, and Arena Lab. What is CAIS? CAIS stands for Collaborative Artificial Intelligence System. It's a system where human being and robot collaborate to achieve the same goal and eventually shares the same space. So the system is built on trust and ensures safety. We have such a system at the Arena Lab. We have a demo of it. In particular, we have a CAIS that is implemented with a machine learner. So the artificial intelligence component is implemented as a machine learner. The automated controller of a robotic arm aims at detecting and classifying objects on a conveyor belt. The objects are classified by color shapes, for example. A human being demonstrates the classification to the robotic arm. The camera captures the gestures of the human being and transmit it to the automated controller via kinetic technology. The learning of the machine learner occurs online. Also, the demonstration is online, and the position and the direction and speed of the human being is online. There are a few risks related to this system. For example, distance violation. So the distance between the robot and the human being can be violated because the motions occur online. And then the human being can be injured. Another risk is that an ML, the machine learner, is not able in the time due to classify the objects, or the robot might prevail on the human needs. The fact that this system is in production also integrates into the overall view a certain amount of uncertainty. For example, the human position or the human motion speed, the human background contrast and luminescence of the working area, and so on. So our approach aims at defining risk-driven assurance methods for ML-equipped CAIS. So we started by using an existing model of risk ML, that is being provided by one of our authors, Susi, and his previous work in 2014. The risk meta model consists of 4 components: the goal, that for us would be the shared goal of the CAIS, the situation of risk, the indicator of risk, and the event of risk. To this model, we added a new component due to the specific case of the embedded system, which is a domain feature component that controls the situation of risk. So, for example, if in our CAIS the goal is the contact does not happen, the risk will be insufficient distance. The situation will be close interaction between robot and human being. The event will be a change of the distance between the two. The indicator will be that the robot and human being are in the same shared space. The domain feature may be related to luminescence and its change during the execution of the operations. So in our paper, we modeled 2 types of risks as an example: the insufficient distance we have just seen and the poor AI quality. So when the machine learner doesn't reach the due accuracy. This model of risk is integrated into the risk-driven assurance process. In particular, the model provides the domain feature space from which we start the process. We search in this space the domain features to classify the goals. These features define the different domain configurations under which we design the assurance cases. They, of course, are also defined through the relevant indicators of risk. We execute the assurance cases, and at the same time, we monitor the behavior of the guys at runtime. In this way, we can collect data and quantify the risk. Then we verify whether the risk is acceptable with respect to the goal of the system. If the risk is acceptable with respect to the goal of the system, we can explain the behavior of the system by the domain features we have used and feed back this information to the extended risk model. If the risk is not acceptable with respect to the goals, then we explain the violation of the goals by the domain features we have selected, and we feed back this information again to the model of risk. At the same time, we also search again in the space of domain features by importance sampling, so features that are more relevant to our problem. We updated the prior distribution and we execute again the assurance cases. And again, we can quantify the risk and evaluate whether it's acceptable with respect to the goals of the system. And this is a continuous loop until we are satisfied or the budget is over. This is our envisioned process, and we intend to implement this process in our demo to provide evidence of the effectiveness of the process.
Thank you. So we are now live, and we have Michael, Barbara, and Angelo here. We have only one question. One is from Silverio, says, great talk about the risk machine learning model. How could it work in operation? Avoid a goal is not fulfilled. Also, can the risk be mitigated collaboratively among several layer-based systems?
Okay, this goes a bit far. For the moment, this is our risk model of risk is based on existing risks of Angelo. Susi is here also as an author of this paper. And the idea of our model of risk is to incorporate the environmental variables as uncertainty in our overall model. So, and this is our, let's say, contributor to what we have seen also to Lionel's keynote this morning. And we don't have applied yet our overall process. We have a demo on which we can apply. So I cannot answer on a more complex, let's say, system. But maybe, Michael, you wanted to go on saying something?
Yeah, I mean, at least the goal-oriented approach is to initially start from regulations and drill it down to concrete risk measures, right? And then based on assurance methodologies, we will have a Bayesian approach to mitigate risks and observe how it is reduced over time. But I would say the goals are the starting point from the regulations to formulate it into the quantitative world of machine learning, I would say.
Yes, and then our idea is to have this loop that also feed back to the model of risk, the initial one, maybe based on regulations or evidence from the context, and then is feedback until let's say we are satisfied and the requirements are satisfied.
Thank you. Last question from Jane. Could you position this against current risk hazard analysis and management approaches such as FMKs or safety assurance cases? Are there things you model that wouldn't fit into these standard approaches?
Michael, you want to answer this on risk?
Yes, I mean, it's, let's say, it somehow integrates with these approaches, I would say. We also, we start from high-level goals and we consider safety assurance cases as intermediate representation, and then put our approach into the loop, I would say. So I think we have it in mind even to integrate it with it, right?